Hello, my DevNation friends. Welcome to another Tech Talk. And today we are going to be discussing Java APIs, how to make good APIs and bad APIs or not. And today's special guest is my friend. He's also a Java champion. He has a super nice accent, speaking directly from Italy, Milan, or very close by. And I have to tell a fun story about Mario. And Mario spoiled me very much when I visited him in his hometown of Gorgonzola. Yes, the cheese one. And I tasted the real Gorgonzola and the best lasagna ever in his house. So that's why I'm so glad to have him today here talking in this Tech Talk. Mario, thank you very much for joining us at DevNation today.
Hi, Edson, and thank you for having me.
Yeah.
So, yeah, just a few words about me. I'm Mario Fusco. I work for Red Hat. I'm the project lead of Druls, the rule engine of Red Hat. And I'm, a Java champion, as Edson said, and the coordinator of the Java user group here in Milan. So today I want to speak about how to design a nice to use Java API. So what is a Java API? The Java API is just the protocol that you use to interact with a program. So it's the interface between your stuff and the library or the framework that are you using. So if the two things are not really well aligned, you have an effect like this, which is not really nice. So an API, in essence, is just what you as a developer use to achieve some task, whatever it is. And you use, I guess, hundreds or thousands of APIs doing your day-by-day job. So again, yeah, it's just a contract between you and the provider of the API. Generally, you are the consumer of the API, but this is not said. I mean, why should you care on how to design a good API? Because 99% of time, we are the consumer of an API designed by and implemented by somebody else. But sometimes we are on the opposite side of the desk, and we are the one who are called to provide a service to implement an API to be used by others. Okay, so when we are in this situation, we should know how to design a good API, and I tried to list here the basic principle to write that I consider the one that are important to create, to design a nice API. And as you can see, there are a lot of them, and some of them are orthogonal, some of them are let's say also in contradiction. So design a good API is also a trade-off. So your API should be intuitive, should be easier to be learned. Ideally, you should be able to use it even without reading the documentation, but it doesn't mean that the documentation is not important. Actually, your API should have a really good documentation, and it should be flexible and easy to evolve, because the software in general and an API in particular is not something static, is something that will evolve with time, and it should be designed at the right level of abstraction, meaning that your user shouldn't care about the implementation detail of your implementation. Again, there shouldn't be leaky abstraction. Okay, and since we are speaking about Java, it should use correctly. It should make a good use of the time system. Should have a limited number of entry point, and something that is very important to me, it should follow the principle of least astonishment. So you shouldn't be surprised of something while using that API. So this is the general idea, but I wanted to give some very practical examples. So I spoke about documentation already. quite often I see a Java docs like this. So set name is the setter of the name. Yeah, okay, whatever. And this documentation looks very similar to this one. Is not very useful, right? But it doesn't be like that. Even for a simple setter, you should be able to say which are the precondition, which are the allowed value, what happens if you pass a value that is not allowed, and stuff like this. So and another thing that is very important, you should, for instance, say if this method is thread safe or not. What happens if the method is called concurrently by multiple threads? So this is something that you not often see in Java docs, in documentation, and when you don't find this information, you just have to guess and make a reasonable guess. Sometimes you have to guess a lot. You have if you have a class totally without documentation, you could find up in this situation. I'm adding what, I'm getting a date. What is the date? What's the difference between the method that sounds similar and stuff like this? So it's a lot of guesswork again. And if you clearly document your API, you will save your user from a lot of guess and a lot of related errors. Okay, so this was about the documentation. Now let's speak a little more closely about the code. So one thing that you often see in API is that you have the so-called convenience method, meaning that you have often lots of overload method with the same name, taking a different set of argument. And of course, the primitive type in Java are one of the cause of this methods proliferation. Yeah, for instance, yeah, I'm taking a very evident example that comes from the standard Java library, which is the string builder, which is very nice. But sometimes you have a time to figure out why you have so many overloads. Is an append of a char sequence different from an append of a string? Why I have two different methods for this? I don't know. It can be much worse than this. So I'm trying to create a simple interface here, a simple API to define stock orders. Can you tell me what you see wrong in this? A few things actually. First of all, again, I believe I have too many overloads for this by method. It is quite confusing. Yes, I need it for business reason because I can have a simple price, or there could be a commission, or the price could be a range. Okay, but even though it is confusing, this is another common mistake that I see quite often. You may have an inconsistent argument order. So why the sell and the buy method has the order of the argument that is inverted between price and quantity? This does make much sense and make the API harder to use. And finally, yeah, not only we have a lots of overload, but we have a method with a long argument list, and even worse, in this case, they are argument of the same type. So it's even easier to pass the right argument at the wrong position. So how can we do better than this? I, for instance, suggest to do this. What I'm doing here, okay, first of all, I'm giving a consistent order, and then I'm encapsulating all the different possibility that you have to define a price for the stock order in the proper price class. So yeah, I'm leveraging the type system, and I'm encapsulating all the complexity in this price class. So it's this price class that we carry the information about if it is a fixed price or a range, or if you have a commission. Okay. About these convenience classes, you should often consider of creating them of allow user not to directly invoke the constructor of your classes in your API, but you should give them the possibility, or only the possibility, to use static factories methods instead. Why? Because in this way the user have a nicer syntax. They even don't have to use the new keyword, and then you have much more flexibility, because you are not if you call the constructor of the price class, you are constructing an instance of that class. You don't have any chance of doing something different. By invoking a method, it gives you lots of flexibility. So you can return different subclasses, or you can return a special value when some precondition is met or not. Okay. So again, nicer syntax, lots of flexibilities, and it's easier to evolve. Another thing related, but somewhat related, but also important, is that what I really like is using Fluent API. So when I have to define this price, I don't want to call this set one after the other, but I like to provide a Fluent interface to define this price. And in this way, the code is much more compact, because I can concatenate multiple invocation, and instead of having to also put the value into a variable before using it, I can use directly it inside the statement that I want to invoke. So if you look at these two piece of code, they are doing exactly the same thing, but the second one, it's doing everything in one statement in a very fluent way. So I believe it's more compact, but you know, it's not really important to save typing. It's important that it's nicer to read. It's more understandable when you read it. And of course, one of the most common example of Fluent API in the native Java API is the stream interface. Everybody are quite familiar with it now. So and it's very nice. Here I'm reporting this just because I wanted to show another problem with this class that is not really related with the fact that it's Fluent, but as you can see, here I believe we have some name inconsistencies, because if you think about it, limit and take while do exactly the same thing, one on a fixed value and the other using a predicate. So it doesn't make much sense to use two different verbs. You are creating a naming consistencies in this way. So probably the limit method could be just called take, or the take while method could named limit while, but you should use the same word for things that do the same thing. That will be easier to understand. Another very common suggestion is that in your API, to improve reusability, flexibility, and evolvability, you should always use the weakest possible type. Okay, so here I'm concatenating an array list of string, and I'm providing this method to my user in my API. But in reality, in my method, do I really care if it's an array list or a linked list or another kind of lists? I don't. So I can generalize, but transforming this in a list. And I also don't care about the order of the item here. So the list could become a collection. And I also don't care about the size of this collection. So the collection could become an iterable. So you do this exercise again and again and again, always rising the level of abstraction till you reach the weakest possible time. In this way, I make the range of usability of this method much broader, because before you can only pass an array list to this method, and now we are allowed to pass any sort of iterable. So yeah, I said this. In this way, you are improving the usability of this method. And this is not only important for the argument, but also for the type that you are returning. Okay, so here I have a person, and I want to collect all the addresses of the other person that are in the family of the person passed as argument, and I'm collecting them in a list. But at some point, yeah, first of all, it's not meaningful for the user that this is a list, that it is a fixed order, because in reality, in the logic of this method, there isn't any fixed order. And moreover, thinking twice, you would like to not have duplicate in this list. If two person in your family live at the same address, which is of course very likely, you would like to have that same address multiple times in your list. So what you do? Yeah, the fix is obvious. You transform the list into a set, and you are done. Unfortunately, you aren't, because now your method has to return a list. The value returned in the signature of your API is a list. So you cannot return the set as it is. This doesn't compile. And you can, at this point, you cannot change the returned type, because otherwise you are breaking the backward compatibility. You are breaking the existing code of your users. So the only thing that you can do at this point is creating an expensive copy by creating a list starting from the items that you have in the set, which is expensive and wasteful if you think about it. So if instead of creating in the first instance, instead of returning a list, you returned a collection. So the weakest possible type, you wouldn't have this problem at all. You could change the list into a set, and your job will be done. So once again, even in the return type, using the weakest possible type, it's a way to improve evolvability of your API. Okay, another very nice thing that you can do for your users is to make your API to support lambdas. So let me give you another practical example here. I'm registering a listener for 2 events. This listener is listening for a before event and an after event. So I'm passing it an interface with 2 methods. And this means that when I'm registering this listener, I will have to create a proper class. In this case, I'm creating an anonymous inner class. I mean, this is not a functional interface. It has 2 methods, so I cannot implement the listener as a simple lambda, as I would like to do. And yeah, the way to solve this is pretty obvious. I split this listener into listening interface, and in this way, yeah, probably you are only interested in the after method or in the before event, sorry, or in the after one, and then I can register to listen one of the two, but just passing a lambda to this method. I don't have to create an anonymous inner class anymore. Okay, and if you think about it, for this specific method, this happens quite often. At this point, I don't have to define my functional interface at all. The consumer interface provided by the native Java API is perfectly fine in this case. Okay, so let me move to a slightly different topic. I'm speaking about this because there is always a lot of discussion about optional, but I believe that this is a class that everybody knows now, so everybody knows of what I'm speaking about, but there are a few interesting things that can be discussed about this class. Okay, somebody called it the mother of all backshedding because, yeah, every time you speak about optional and how to use them properly, you end up with endless discussion. My opinion about how this class has been implemented. First of all, I believe this is my opinion again. I'm speaking for myself, but the first time I used this class, this was breaking the principle of less astonishment for me. Why? Because my idea was, okay, I don't want to deal with null pointer exception. I don't want to have null pointer exception anymore. And this is why I start using optional. And guess what? The off method, the static factory method of optional, may eventually throw a null pointer exception, which is totally surprising for me. I'm really astonished of this behavior because I wanted to use optional to avoid null pointer exception, and I got a null pointer exception while using it. And then I believe, you have a couple of static factory methods, this of and of nullable. I consider the shortest name of the default factory method, the default way to create an optional. And if this is the default behavior, I believe it is at least the wrong default. Why? Because it throws a null pointer exception, which is something that I don't expect at all. Okay, so I believe that the off method could be totally replaced, and the off nullable should have been named off and be the last real factory method of this class. This is what I wrote in a few in a blog post, and also I tweeted about it. And of course, I got some feedback on Twitter of this, so I started discussing this thing with people on Twitter, and I'm posting some of the tweets here, not because I wanted you now to read the tweet. They are quite verbose, but you can use it as a reference later. But I wanted to show a few points about this very interesting discussion. So the API design is an iterative process. You have your own idea, but then you discuss with other, and you see different points of view. And by doing this, you will realize that people may weight different feature in different way, as a way as I said, designing a good API is a sort of trade-off. You have to do some compromise, and what is important for you cannot have the same importance for others. And probably not only things could be more or less important than you think, but by discussing stuff, you could see other things that you weren't thinking at all. So, for instance, Trisha, who is another Java champion, I guess many of you know her, was telling me, look, you don't like the of and of nullable distinction, but I use it a lot in my code. And I didn't realize this. And again, a good API has many different characteristics, and you have to balance between give people more power and more simplicity. And of course, the two things are often in contradiction, and you have, again, to find compromises. And yeah, I told you, writing a good design and a good API, it's always a trade-off. And this is a very important thing. The intent could not be clear. That should be the first thing that you should clarify. The intent could be misunderstood, because the first thing that I said when I presented the slide about optional is that the intent that I expect for that class was to allow me to forget about the null pointer exception. Okay, this is the intent that I was expecting in it, that I was reading in it. But somebody make me notice, look, this was not the real intent, or not the common understood intent. The intent was just saying that a value could be there or not, but if you're passing a null to an optional, maybe you want a null pointer exception. So probably I misunderstood the intent, or I gave to that class an intent that is not one that the designer of the class had in mind. Okay, so to recap, so again, the reason why I showed you all of this is to really underline that designing a good API is an iterative process. You do this, the first one, and then you start using your API, and probably you wouldn't like your API at all. So you do and redo this multiple times by defining unclear intention, removing the duplicated or redundant code, and removing the leaky abstraction. And you do this by eat your own dog food, meaning that you write lots of unit tests against your API, and while writing those unit tests, you will see this thing is not really nice to use. I don't like it. I don't like use this API this way. And if you don't like to use your own API, you can be sure that your user will not like it as well. So it's a reason why you should review it again and clean it up again, and make the intention clear. Okay, so yeah, and that's all for me. Again, there was a lot, and I understand there were a lot of personal opinion in this talk. They come mostly for my day-by-day experience as a developer. You may have done different experience or seen different things and different problems. So I'd really like to continue the discussion about it. Feel free to ask questions if you want. I believe it's a very interesting topic. And that's all for me.
Awesome. Thank you very much, Mario. Yes, design APIs. And of course, anything related to programming, like there's always some controversial opinions. We had a nice discussion here in the chat. And I was able to collect 2 questions that I'm going to post right now for you. Here, now I'm noticing that it's kind of small, but I'm going to read it. So Vladi is asking, when is the right time to encapsulate complexity in price class when you showed the example? What would be the rule of thumb for it?
Well, when you have two arguments, two things that often goes together, that you should considering already encapsulating it. But really, it should be also your domain model, your business model to drive this. Okay, so look again at my price example. In the business model of order in stock, the very simple one that I invented there, you have in that model this complex way or not trivial way of defining price. And you want to encapsulate it in a proper class. You don't want to pass around 3 arguments, 3 doubles, instead of describing an API, especially an API for programming language with a strongly typed system like Java is made of this. It's made of defining your domain object, your business object. And in my example, I think it was evident that the price definition was a business object, a domain object of your business. And this is the very first thing that you should consider. You should consider while defining this API. And another thing, often, this is called the primitive obsession. You use you have the primitive type, you have the numbers of the primitives and the strings, and you fill your the signature of your method with string, ints, and double and big decimal and whatever. This is really the primitive obsession. You are obsessing of using primitive. You are not put the domain knowledge in your code, and then you are creating a semantic gap between the code and your business model. Then you have to fill later, and it will be worse, of course.
Nice. And next question from Jordi. Do static factories work well with CDI?
No, I don't think so. Or I think you should be pay attention with it. I mean, you can define your producer in your CDI wiring, so you can say, and you can use the factory method in the producer and wire, and when the wiring is called, the producer will call the factory method internally. But yes, you have to do some more gluing work to make this work with CDI. I agree on this. This is a pain point. Yes.
Yeah, maybe that's a nice addition to CDI 3.0 when it comes out. And last but not least, I have a question from Jacob, and I'm going to read the entire question because it's on the chat. What is your opinion of encapsulation? My personal preference is for optional abstractions, so I can peel layers of an API off if I need the increased control provided by the next layers.
Yeah, okay. So this is somewhat related with the first question. Yes. When I have 2 double around and I repeat them again and again, I prefer to encapsulate it. This gives me also more freedom and flexibility. Yeah, this is another thing that probably I didn't underline enough again during that price example. Let's suppose that at some point somebody tells you, look, we need a fourth double, a fourth argument for a special situation of price definition. If you spread around your signature with a lots of double in it, you will have to change your signatures. If you have the price, the concept of the price encapsulating in your domain object, all the signature using it will remain exactly the same. You don't have to change anything. Everything is encapsulated in the price. So this is another reason why also this help with evolvability. So yeah, I'm in favor of encapsulation whenever possible. Of course, this if you are a performance maniac, you may say that you are creating too many objects this way. This could be true, but your code is in your code. The performance are important only in the 1% of your code generally. So you can be maniac of primitive performances only there, and you should strive for clarity in the other 99% of the code. So what I usually say is that you can resolve any programming problem by adding one layer of abstraction, and you can resolve any performance problem by removing one layer of abstraction. So you have, once again, it's a balancing effort, but yeah, in the 99% of cases, good encapsulation it's a winning choice.
Awesome. And we are out of time today. Mario, thank you very much for this super interesting presentation. We had a lot of comments of the chat. I'm pretty sure that people will keep thinking about the subject during the weekend.
Yeah, by the way, if you have other questions, feel free to ping me, contact me on my Twitter account, and I will be happy to continue this conversation offline. Thanks.
Awesome. Yes. And I said, thank you very much for joining us at DevNation. If you're interested, don't forget to subscribe to DevNation channel. We have great content every single week posted online for you. And for you, Mario, again, it's great to see you, even though it's online, my friends. And hopefully next time we meet, we'll be able to get that pineapple pizza together with ketchup. Yeah, I'm sure you're eager for that.
Yeah. Okay.
Thank you.
Bye, Edson. Thank you for having me. Bye, guys.